Okay, so this is the final question of this paper, and let's see what it says. A fixed rough plane is inclined at an angle alpha to the horizontal where tan alpha is equals to 5 upon 12. Okay, so immediately whenever I read tan alpha, my go-to reaction is to find out cos alpha and sin alpha, because we know that at some point we're going to use it. So if tan alpha is equals to 5 upon 12, that means sin alpha will be equal to 5 upon 13, because the opposite is 5, the hypotenuse will be 13. Okay, and cos alpha will be equal to 12 upon 13, because the adjacent is 12 and the hypotenuse will be 13. Okay, now the question says a small smooth pulley is fixed at the top of the plane. One end of a light inextensible string is attached to a particle P which is at rest on the plane. Alright, so here you can see, here's the pulley, here's particle P. The string passes over the pulley and the other side of the string is attached to a particle Q, which is right here, which hangs vertically below the pulley as shown in figure 5. Particle P and M, particle P has mass so and so, Q has so and so. The string from P to the pulley lies along a line of greater slope of the plane. The coefficient of friction between P and the plane is mu. The system is in limiting equilibrium and the string taut and P is on the point of slipping up the plane. Okay, so that is some very important piece of information which will come in handy shortly. So first thing we're going to do obviously is that we're going to copy this and we're going to paste it here. And we're supposed to find out the value of mu, and it's an 8-mark question. Okay, then that means there's definitely a decent amount of working that we have to do. So the first thing we want to do is we want to break down the forces. Okay, so let's start with Q because it's easy. So we know that there's the weight of the particle acting downwards, that would be 0.5 mg. Tension acting upwards. Now let's talk about P, the weight acting downwards. Okay, then this is the component perpendicular to the plane. This is the component that is parallel to the plane. So this will be alpha. The weight would be mg. Okay, and this would be mg sine alpha. And this would be mg cos alpha. And here's tension. Now, although it's in limiting equilibrium, but it's on the point of moving, P is on the point of slipping up the plane. So that means the direction in which it will move is up the plane, and I like to show that with the double arrow. And if it's about to move up the plane, that means the frictional force will be acting down the plane. Okay, now let's talk about P first. So if I make the net force equation for P, so that's basically the force due to which it will move up the plane, that's tension, minus the two forces acting in the opposite direction. One is obviously its own weight component. Okay, also just realized that there will also be a normal reaction force here. Okay, don't forget that. So the two forces acting on the opposite side will be the weight component, that's mg sine alpha, plus the frictional force, which is equal to mass times acceleration. Now it's in limiting equilibrium, that means acceleration is equal to 0. Okay, so that means we have T minus, since sine alpha is 5 upon 13, so 5 upon 13 mg, plus the frictional force, which is equal to mu times r. And by the way, r will be equal to mg cos alpha. Okay, because it's in equilibrium and there are no other forces that have perpendicular components. So the normal reaction force will be equal to the component of the weight that is perpendicular to the plane. Okay, so this will be minus, since we opened the bracket. So minus 12 upon 13 mg, that's the normal reaction force, times the coefficient of friction, which is mu, is equals to 0. And this right here is our first equation. Okay, so we're going to hold on to this. Now let's talk about Q. So Q would be 0.5 mg, since that's the force due to which it's going to slide down, minus T, which is equal to 0.5 mg. And this right here is our second equation. Sorry, this is equal to 0, mass times acceleration, which is equal to 0. Now, let's, in fact, you know what, let's write this as mass times acceleration first. And since that is acceleration is 0, so T is equals to 0.5 mg. This is our third equation. And since this has come with the help of the second, we're going to plug it in the first equation. So we get 0.5 mg, okay, in place of T, minus 5 upon 13 mg, minus 12 upon 13 mg mu is equals to 0. Okay, now a good idea would be to multiply everything by 13. I think that's a good idea. Multiply everything by 13. So this becomes 13 into 0.5, that's going to be 6.5 minus 5 mg. Okay, and don't forget that this will be 6.5 with mg minus 12 mg mu. Now 6.5 mg minus 5 mg, that would be 1.5 mg, and let's shift 12 mg mu across the equals to sign, so that would be positive 12 mg mu. Now we cross out mg from both sides, mu is equal to 1.5 upon 12, and now solve for the value of mu, write it in fraction form, which is equal to 1 over 8. And there you go. So not as much working as we initially thought. But yeah, there are a lot of things that are marked in between. So that is why this was an 8-mark question. So anyway, I hope that's clear. Now the question says the string breaks, okay, and P begins to move down the plane. Okay. When particle P has traveled a distance of 0.8 meters down the when P has traveled a distance of 0.8 meters down the plane, the speed of P is v. Find the value of v. Okay. Now, so once the string breaks, that means the tension is no longer there. Okay, so this is no longer there. Now this particle is now moving down, and why will it be moving down? It's moving down because of its own weight component, the weight component which is parallel to the plane. That is the force due to which it will move down, and that is basically mg sine alpha. Now if the particle is moving down, double arrow means the direction in which it's moving. That means the frictional force will be acting upwards, up the plane. Okay. Now, as soon as the string breaks, that is when the particle starts moving. That means the initial velocity will be 0. And according to the question, this particle slides 0.8 meters, and that is when we're supposed to find out the velocity. So first thing we need to do is we need to find out the acceleration. Okay, so this is the working for part B. Now we need to find out the acceleration, for which we will use the net force equation. Now the force due to which it's moving down, that's mg sine alpha, minus the force acting in the opposite direction, which is the frictional force, equals to mass times acceleration. So this is 5 upon 13 mg minus mu, which we've worked out to be 1 upon 8. And what's the normal reaction force? The normal reaction force is equal to the component which is perpendicular to the plane, and that would be mg cos alpha. So 1 upon 8, 12 upon 13, that's cos alpha, multiplied by mg is equals to mass times acceleration. Now when you simplify this, 5 upon 13 minus 1 upon 8 into 12 upon 13, you get 7 upon 26 mg, which is equal to mass times acceleration. That means acceleration, the exact value of acceleration is 7 upon 26 g. Now we're keeping this exact because this is not the final answer. Now we know the acceleration due to which it moves down the plane. Okay, we know the acceleration, we have the distance that it travels, we have the initial velocity, and we need to find out the final velocity. So what's the appropriate equation? It's 2as equals to v square minus u square. So 2 times 7 upon 26 g times 0.8 is equals to v square minus 0 square. Now obviously you're going to need your calculator over here, and when you work out the value of v, take g to be equal to 9.8. So v turns out to be 2.0546, and correct to 3 significant figures, it's going to be 2.05 meters per second. There you go. That's the answer. And that is the end of this question and also the end of this paper. Now, I hope it's all clear. I will encourage you guys to, pause these questions as I'm solving them and solve them yourself, and just keep testing yourself. And let me know what your thoughts are about the difficulty level of this paper. I'll see you guys inshallah in the next video with another paper. So until then, take care. Allah Hafiz.